run a Sage workshop. I had attended one before. I absolutely enjoyed it. I got a lot out of it. And so I thought this would be great for you guys as undergrads. He is the main author and director of the Sage project that you guys are going to be working with, which is a popular alternative to expensive commercial software. And then one last thing I want to say is during his free time, he enjoys skateboarding. And I think I heard a rumor about you're building something, a skate ramp or a skate park or something like that.
We're building a big skateboard ramp. Very big.
So anyways, let's welcome Dr.
Seattle.
Stein.
Thank you. All right, so this workshop will be about Sage, which is a program that lets you freely do mathematics over the web, so in your web browser or through your phone. But also it's a program that you can download and run on your own computer if you want to do pretty sophisticated mathematics. And what I'm going to do is, one of the main goals is to get you going so that you'll actually try out some of the examples that I show and try variations on them for yourself. There'll be many points during this workshop where I'll kind of stop talking up here, let you try out some things on your own computer, or if you forgot your computer and you have like an iPhone or an Android phone, you can use that as well. Or if you have an iPad, you can use that. And you'll try out stuff and I'll just walk around with Edre and Alondra and answer your questions, okay? So, and I'll make sure that everybody is able to use Sage. So to get started, I've made a website which has some links to some Sage notebook servers which I set up specially for today. The internet might be a little bit slow in here, but at least the notebook servers will be pretty fast and work well. So you won't have to compete for resources with other people outside of this room. So the first thing you should do right now is choose a random number that's either 1, 2, 5, or 6 for yourself. Don't all choose 1. I just wanted to, I set up 4 different notebook servers. These are websites that you can use the Sage Notebook through. Currently, the Sage Notebook isn't smart enough to automatically spread itself between a large number of computers. It will be in the future, but right now it isn't. So what we'll have to do is just, if you decide you like 5, then you can choose that one. Somebody else will choose 2. So as long as you somewhat roughly and randomly spread yourself out between these numbers, everything will be fine. So to get to this website, go to my website, which is wstein.org, and then click on the big SACNAS link. And my website's right here. W. Stein is just for William Stein. And the link for SACNAS is right in the middle of the page, and that has this. Okay? So again, it's wstein.org, and then you just click on the SACNAS link. So all you have to do is remember wstein.org. And then you'll come here, and what I want you to do is to click on one of these links. Just choose one, I don't care which. Just don't all choose the same one, I hope. And when you click on one of the links, you'll get sent to a sign-in page. So I'm just going to walk around the room, and I hope everybody sees I hope to see this on everybody's computers. And what you should be doing is clicking on this link that says sign up for a new Sage Notebook account. This will allow you to just choose any login name you want and a password. You don't have to use OpenID or Google or anything like with the other server that I had mentioned before. I just set these up today, so it should be pretty quick to use. So you just click here. You get to choose a username, a password, retype your password, and then you can log in at the screen you were just at. Okay, so all you have to remember is go to wstein.org. I'll just kind of add that right here, wstein.org, and click on the SACNAS link, and then choose one of the notebook servers. Okay, so do it. If you have any trouble at all, just let me know. It's totally blank. Oh, there it is. All right, excellent. So there you are. I already have an account. So it looks like everybody's doing this or has done this, and then we'll log in. And what you should do, as it says right here, the next step, step 2, once you log in, click on the link that's labeled published, which you see at the top. So it's loading for me. I made one huge worksheet, so it takes a while to load, but that's what's being loaded right now. So you click on the link that's labeled published, and then there'll be one worksheet that you can click on that, and then click on edit it. This should take a little bit of time, so don't think it's instantaneous. And I'll walk around and make sure you're able to do this. And when you successfully do that, what you should see is this, which will be the talk and also a lot of examples that we'll try variations on and so on. It's a pretty big worksheet. It has a lot of information in it, like a whole bunch of image files, a 3D model of Yoda, and so on. So that's why it takes some time to download. So the instructions are right here under step 2. You log in with the account you just created, click on published, and then click on the worksheet that's listed there. There's one worksheet under published called SACNAS. And when you click on it, then in the upper left, you'll see edit a copy of the published worksheet. And you should click on that. Not only get a full copy of this worksheet that you can change however you want and make it available to you. So for example, it's right there. It says edit a copy. And it'll take a little while for it to download the copy to your computer. Which network page? So, yeah, I don't think you said anything about the non-free network, which people might try in case the free one is working on. I think we have an account on a non-free network, just in case. So you might want to use that.
If you go to a regular internet, the username is VOLS. I think it's actually VOLS, the username, and the password is not. Yeah, so there's a free one, but in case it's too slow, you can also try the other, the regular internet.
Well, you can just use it for go to the top of the edit copy. But it's not edit. Your object? Yep. That's edit copy. And if you get to the worksheet, you can try, you put the cursor where it says 1 plus 2 plus 3, testing, in the very top of the worksheet. You should be able to click on evaluate and get the result of 1 plus 2 plus 3. So, and you can change that, like you can change that to something else if you want, and I encourage you to do so. Try that. And if you have any trouble and it doesn't give you the right answer, it's 6. And let me know. Okay. Probably it's still on the server. This is a copy that sometimes it's also still very perspective. A lot of JavaScript that we can't get but now you can put that you can also use a pure symbol like the text. Okay, any questions? Everybody able to evaluate something? Any questions? All right, so let's move on with this. So, wow, it hasn't finished downloading for me. That's terrible. Okay. All right, so I'm testing it out, and it works for me too. I'm able to compute things, which is a good sign. Okay, so now I'm going to give you kind of a 20-minute background talk about what SAGE is and where it comes from. If you get really bored, just try some examples farther down on the worksheet. If you don't pay attention, that's fine. Make sure I ask lots of questions. All right, so here we are. This is the like this. This is the SAGE logo. Looks like SAGE, but also has a little infinity in the middle. It was designed. This undergrad was working on SAGE, and his little brother in San Diego designed the logo, and then he like on a piece of paper, and then he like cleaned it up and made it look nice. So that's where it came from. And then the background illustrates various plots that were created using SAGE, involving here. This involves a matrix. This involves a curve, a cubic curve. This involves some sort of graph, and this is a kind of calculus style plot. Okay, so here's an attempt to answer the question, what in the heck is SAGE, in one single slide. So first we have a mission statement. That's our goal, the goal of the project. So it's to create a viable, free, open source alternative to Magma, Maple, MATLAB, and Mathematica, where the order of those 4 programs depends a lot on what you care about. For me, as a research number theorist, I care a lot about having a viable alternative to Magma. Many people in engineering and the sciences would care about having a viable alternative to MATLAB. And people in more symbolic computation areas might care a lot about Maple or Mathematica. An issue with all those programs is that, especially if you get beyond the academic use situation, they start to cost an enormous amount of money. The typical list prices are around $2,000. So they're very, very expensive. In contrast, SAGE is completely free. And by a viable alternative, what I mean is that it has the features of those programs. So if there's a function in one of those programs, that function should be in SAGE. This is not the case uniformly across the board yet. There are many functions missing in SAGE that are in those programs. But there also are a number of functions in SAGE that aren't in any of the other programs. So mathematical software is kind of complicated when you compare it with other mathematical software. It's kind of like, it's a little like a video game where if you compare one video game with a completely different video game, they have features, but it's a whole different world with completely different challenges in each game. So with SAGE, there are things that there's just an absolutely enormous wide range of different types of functionality. If you think about it, I don't know how much math you've learned, but math is extremely broad. There's just, no matter who you talk to and how much mathematics they've been doing, even if they've been doing sort of math for decades, they still only have a real sense of a very, very small part of mathematics. And that's the case with math software in that really trying to address an absolutely enormous field. Even with Sage itself, there's, as far as I can tell, no one person that has a reasonable sense of what Sage does right now. I don't even know what it does. There's massive amounts of Sage where I've never used them, and I don't know how they work. It's just a really, really big program. There's a reference manual. If you print it out, it's like 7,000 pages right now. So it's really, really big. Okay, so features, we want lots of features, and at least in particular areas that we care a lot about, we can compare. We want 3D and 2D graphics, so you can plot things and look at them easily. We want to have a nice graphical user interface and good documentation, which should mean that there are books that use Sage. There are papers that use Sage, curriculum. So if you want to teach a calculus class, then it's easy to calculus problems and lectures and stuff with examples involving Sage. You don't have to do everything from scratch yourself. So we don't want it to be the case that you have to do an enormous amount of work to use Sage in taking or teaching a class. What if your instructor says, I want to use Sage in calculus, and then they suddenly have to make up all the problems that use Sage. They have to come up with all the examples for you. Then it would just be a lot more work for them. So you don't want it to be like that. You want ready to go materials. One thing with Sage is that it's not at all a drop-in replacement for these other systems. So if you've written a complicated program in MATLAB or in Mathematica or something, don't expect it to run in Sage. This is something people often wish Sage could do, but we've just decided that's not what we're going to put our effort into. It's extremely hard to do that. Maybe at some point in the future that will happen, but it's not our main goal at present. So in particular, Sage isn't like Octave. Octave is a program that is free and open source and aims to be a lot like MATLAB. And it, like literally, you can take MATLAB code and put it into Octave, and often it will run in the same way. Sage is nothing like that. That said, you can use Octave through Sage, and I'll show you some examples of that later. So if you have a snippet of MATLAB code, you can, in many cases, use it through Sage, as I'll show via an interface. And some reasons for me personally wanting something and not just being satisfied with Magma, Maple, MATLAB, or Mathematica, personally Magma for me. So I started Sage in January 2005, quite a while ago, and these are some of the reasons that I started the project. So all the programs available to me at the time that had fairly sophisticated functionality related to my teaching and research cost a lot of money, and this there are a lot of reasons that this is frustrating, but you have students and they want to use your software. You have friends who are doing research in similar areas and they have to spend $1,000 in order to get the same program that you're using, and it really kind of slows down collaboration. And I think with Edre, I think when you were trying to get Magma once, it was actually very challenging just to get Magma, even when you had the money. Because with Magma, they don't just sell it on online at Amazon.com. They, at least at the time, you had to email them, hope they would email you back, and then they would FTP it to you or something. It was very barbaric back then. And I think I don't know, I think it's still hard to buy a Magma license, even if you have the money. Another issue with those systems is they're closed. This is still a problem with a lot of them where they implement some algorithm and it's very, very fast. It's extremely impressive how quickly they can multiply two matrices together, or compute a determinant, or solve a system of equations, or compute an integral. And you wonder, how can they do that? And you don't have the slightest clue. And that can get very frustrating, as a researcher at least, because you might think, oh, if I understood how they did this, then I could improve upon it, write a paper, do something better than has been done before. But you can't if you are not allowed to look at the implementation. So that's kind of along the same lines. If you have a good idea about how one of those programs could be made to be better, who do you talk to? How do you get them to take into account your ideas? Usually there's one person at the top that has total control about the direction of the development of those systems. And with Sage, on the other hand, there's a public mailing list. If you have a good idea about how Sage should change or be improved, anybody in the world can just pop onto that list, write a compelling argument, and if you can convince enough people, your change will be accepted and it will happen. And it's completely democratic in that way. And this has happened many, many times. Copy protection can be annoying. So with all of those programs, you install them on one computer, and then suddenly it stops working after a year, the program. Or you try to install on several computers, and you have to buy licenses for each computer. So this can be very frustrating if you Maybe you develop a bunch of code over a year or two in Mathematica, and now you want to run it on a supercomputer. There are a lot of very powerful supercomputers out there, but you need licenses for every single node you're going to run the program on to legally run it on the supercomputer, or to even illegally run it. You can't illegally run it unless it's been cracked somehow, which you don't want to do. So that's annoying. Another issue is all of those programs use their own special purpose language. So they each have a programming language. Mathematica has its own very Lisp-like programming language. MATLAB has a language that's made up that's good for expressing things involving matrices, but very bad for certain types of programming. Maple has its own weird language with all kinds of funny conventions and so on. And it means that you have to learn at least, well, you learn that programming language and you can't use it to do other things that are maybe more general purpose. With Sage, the programming language is Python. Has anyone here ever heard of the programming language Python? Wow, most people in this room have heard of the programming language Python. It's probably the most popular, or at least in the top 3 of scripting languages, that is, interpreted programming languages. It comes with OS 10, comes with every copy of OS 10 has it built in, every copy of Linux I think has it. Certainly very easy to install into Windows. So it's extremely popular programming language. Bug tracking is secret with most of these systems, except with MATLAB you can I think sign up for an account and get access to their bug list. But you know, if you're using a piece of math software where there's a right and a wrong answer, it's not a matter of something looking a little funny, it's either right or wrong, you want to know what the bugs are in case you run into something funny. Also, many of these languages don't have good compilers, whereas Python does have a good compiler. That is something that can turn the interpreted code into much faster compiled code. So these are some reasons why I was frustrated with the MAs. So here's Sage. This is again an attempt to answer the question, what is Sage? And as I mentioned just a minute ago, it's an alternative to the MAs. So it's a program that lets you do mathematics in the sense of doing calculations that are relevant to mathematics. The language that it uses is Python. When you type in stuff into the Sage notebook, you type your code, your expressions in the Python language. Although we did a few things. In fact, the input gets modified slightly so that you can type things like, well, if you type 2 divided by, well, how about even better, 4 divided by 6, you get 2/3, so you get an exact rational number back. If you do that in Python, you'll get 0, which you might find deeply disturbing. Let me illustrate that. So this is just OS 10 on my laptop. I run Python by typing Python. I type 4/6, and I get 0. So it's not really that mathematician friendly. What it's doing here is it's dividing and taking the floor. And for some reason they decided, hey, if you divide 2 integers, you want an integer back. If you divide 2, basically they want it so that division is a binary operation on the set that you're working with. So it takes 2 things in that set and gives you something back in the same set. So that was a very weird design decision. It was basically copying what is done in the C programming language, more or less. In Python 3, I think which is, oh, I don't have it installed on here, but they do something else. Maybe I don't have it installed anywhere. But there's a new version of Python where you get back, in that case, you would get back 0.66666, which still, to some mathematicians, isn't so nice. Okay, another thing that Sage is, it's a distribution. So when you want to get Sage and run it yourself on your own computer, you get all the components of Sage, you get all the dependencies of Sage, you get everything together as one complete piece of software that you can run. If you want to build it from source code, if you're very much into programming, and every single person that seriously uses Sage is a programmer, because anytime you type in code to Sage, you're programming. These are programs that you're writing. This is a very short program, but as you use Sage to do more and more sophisticated things, you might define a function and use conditionals like this. If something's true, do that. This is a 3-line program. So it's very hard to use Sage for anything and not start learning to program. So as you learn to program, you think, oh, maybe I'll download Sage itself, all of the source code of the program. It's an open source program. You can build it completely from source. It includes all of its dependencies. So you don't have to be a super programming wizard to build Sage from source. You download a zip archive, you extract it, and you type one word make. And then you let it sit there for anywhere from 1 to 20 hours, and when you come back, it's built, at least on Linux and OS 10. So it's that plus, so there's a huge amount of code that's in Sage that was not developed by me and in fact existed before the project started. We incorporated many other open source systems and then added a whole bunch of new code on top of that. And that together is what Sage is. So you can think of it as a whole bunch of other existing open source projects and then a brand new from scratch Python library written on top of all those other projects that ties them all together and provides code that implements things not implemented in those other libraries. Okay, so that's what Sage is. By the way, you can evaluate this little function, you can plug in something, and there you are. It's comparing, so in the first case, it's comparing n and m as integers, and in the second case, it's comparing these two strings. And strings are compared in alphabetical order. So this illustrates that, in Python at least, you don't have to explicitly declare the data types of your variables. You can write a function and the variables can be integers, they can be strings, they can be all kinds of different things with the exact same code, which is very nice. It's very different than Java and very similar to JavaScript, if you know that in either of those languages. Here's a little picture I drew that illustrates the sense in which Sage is a distribution. These are various programs with names like Gap, Maxima, Singular, R, Python, and then various libraries like Atlas and LaTeX. These are all included in every copy of Sage. And some of these programs have been around since, well, probably before anybody in this room was born, unless there's somebody that's like 50. Because Maxima was written in the 60s, and there's still code in there, I think, that survives from the 60s, and that's part of Sage. It provides functionality, for example, for computing symbolic integrals and finding limits of functions at points and so on. R, has anyone here heard of R, the statistics program? Again, everybody's heard of R. So every copy of Sage has R in it, and you can use R from within Sage. So if you have like a snippet of R code and you want to use it, and you have Sage installed or you have access to Sage somehow, then you can use it. Okay. Yeah, so there they are. By the way, somebody posted a history of Paris, which is a number theory program in Sage that online today. So this was just posted a few hours ago. And it starts in 1979 and goes forward from there. So there's all kinds of development in the 70s and the 80s and the 90s. I guess a logo was created in 1997. Certain key developers got involved, et cetera, et cetera. So there's like 100 different programs that are incorporated in Sage, and they all have rich histories like this. And then here's a little map which shows the locations of some of the Sage developers. So people who contribute to Sage frequently and let us explicitly post their location and their name on our website, which is not everybody. There's at least 247 such people. And you can see that they're spread throughout the world, kind of equally between Europe and the United States, but there's also people from South Africa, there's a bunch of people in Uruguay, Australia, and all kinds of places. Not so many in Russia, but definitely South Africa has a strong interest in Sage. And open source in general, there's a very strong interest in open source in South Africa. Okay, so my sort of history of Sage, or overview of Sage talks coming to an end, but before I finish, here's kind of just a little history of Sage. So the project started in 2005, as I mentioned, and oh, by the way, so why did I call it Sage? So I was doodling at a conference and thinking about a good name for the software project I was thinking of launching, and the word Sage was in my mind because my wife frequently burns sage. She's sitting right there. So she's Navajo and she likes burning sage. And so I just noticed a lot of sage being burned around me. Wasn't quite sure why, but it's also an extremely good word for acronyms. Like you can just think of acronym after acronym that fits the word Sage. So I thought, whatever I end up making the software do, I can fit the word Sage as an acronym. It's also nice because in French it means wise, and kind of it seems like a reasonable name for something that's like an oracle that you ask questions of about mathematics. So there just seemed to be a whole bunch of good reasons to call it SAGE. An argument against it would be, how could you ever Google for SAGE? Because it's such a common word, it might be very hard to do a search. To do a search for the word SAGE and something else, and have it actually bring up my software. But fortunately, I think it does pretty well when you Google it. So like it's the first hit. But so that's good. And if you do SAGE and then other things, it comes up pretty quickly. I think the results are slightly biased based on me being logged in, but still, it certainly comes up high. So that's why it's called SAGE initially. And it was also initially an acronym for Software for Arithmetic Geometry Experimentation. How many people here know what arithmetic geometry is? I'm not even sure I do, even though technically I guess I'm an arithmetic geometer. It's a kind of special area of number theory that involves lots of things that take a very long time to learn, like étale cohomology and L-adic cohomology and stuff like that. But that was the acronym initially, and then it became Software for Algebra and Geometry Experimentation as more people got involved in the project. Initially, I planned for it to just be a number theory system, but I realized that there are so many things involved in SAGE development that have nothing to do with number theory but need to get done, that it would be better to just, the second person involved in SAGE development was a coding theorist, which is pretty far from number theory, really. So I just started getting lots of people involved from other areas of mathematics. So it was Software for Algebra and Geometry Experimentation for a while, and then in 2007 we just deprecated it being an acronym, so it's just the word SAGE. So it's really meant to just be as broad as any other general purpose math software system to address all areas of mathematics. In particular, it's not just for number theory. Okay, so just kind of quickly going through this. So in 2006, we started having SAGE Days workshops. The second one was at University of Washington here, and the first one was at UC San Diego. And then we had a couple more SAGE workshops. We started actually caring about the quality of the code that goes into SAGE a lot more. We made a 100% testing requirement. Anyone who contributes code has to contribute a test for every function that they contribute. Seems logical, but we actually lost developers. There are people that absolutely refused to contribute code under these draconian terms. So Joe Mueller was one of the guys that just decided to stop for this reason, which was pretty surprising. Somebody entered SAGE in a French contest called the Trophée de Libre, so Trophy of Freedom, and we won first place in scientific software for, I guess, being the best scientific software that year. And then there were a whole bunch of articles, and we got a free laptop. That was what we won. So that was useful. We instituted a peer review for all code. So anytime somebody contributes code, somebody else has to read over and sign off on it. And it's very much like when you contribute an article to a journal and somebody reviews it. So we do the same thing with code contributions. And there's a well-documented description of what you have to do to contribute code to SAGE, what the process is, and so on. It's still, the barrier to entry is still pretty annoying, though. I'd like it to be as easy as changing Wikipedia as far as contributing code to SAGE goes. It'd be nice if you could pull out your phone, start browsing the documentation for a function, make a modification, fix a typo, and submit that. That's not the case right now, but it's something that I hope to change. I want to make it much easier. In fact, I was teaching a workshop to a bunch of high school students this summer that use SAGE a lot, and one of them found a mistake in the documentation, and I'm like, you can fix that? And then he started just trying to use the web interface to fix it, but it's not possible. You have to download all of SAGE to your computer. You have to build it. You have to make the change there. You have to create a patch, which is a file that describes the difference. You have to get an account on a certain server and then post your patch to that server. Then it has to get reviewed by somebody, and so on. So it's just, there's a whole bunch of steps. Nonetheless, there's still hundreds and hundreds of people, around 500 that have gone through all these steps and contributed often substantial amounts of code. In 2008, I was doing an enormous amount of work. Basically, almost full-time, I was just taking all the code people are sending me and putting it into SAGE and making new releases and testing them. And I realized that I wasn't the only human in the entire world that could do that. I don't know, for some reason I had this bizarre feeling that I was the only person that could possibly put together a SAGE release, and nobody else could do this. I don't know if have you ever done anything where you feel like you're the only person in the world that can do it? Were you right? Probably not. Or maybe you were for a little while, but but only for a little while. So I found other people. I just said, we just kind of got people to volunteer, and several other people started doing this. And not only could they do it better than me, which was surprising. And now I think I've done maybe 1 or 2 releases since this date. And there's a guy right now, he's a young faculty member in Belgium named Jeroen Demeyer. And he's made, I think, all the releases for the last 2 years. And he's extremely good at it. Just this like wiry, very energetic Belgian guy. I don't have to pay him anything, and he does an extraordinarily good job. So it's pretty cool. So then you'll notice a huge number of these Sage Days. Sage Days are week-long workshops where people come together and work on Sage code. And don't think that so first, everyone that goes gets all their expenses paid, which is nice. And they've happened in all kinds of places, like in San Diego, and we've had many up here and other places. There have been many undergraduates. I think most of you are undergraduates. There have been many undergrads who have contributed to Sage and been people who come to the Sage workshops. Often undergrads are very, very good at programming. They really like programming, and they do an extremely good job. So if you want to get into Sage development, you could easily come to a Sage Days workshop. Every single one is listed on the wiki. We have plenty of funding from the NSF to cover travel and hotel and all that sort of thing. And we have one about once a month somewhere in the world, all over the place. Okay, and there you are. And by the way, I have a little link to an article where I wrote down a lot about what happened before 2005 in my personal life, starting with me playing around with calculators when I was a little kid. So, okay, so that completes giving you a background and overview of what Sage is. And we'll just pause for a bit. And basically, I want you to ask kind of random questions about what can you do in Sage, how can you do it. I do have a bunch of examples that we're going to go through and play around with in a minute, but it's good to just wonder, like what can you do? How long does it take? What do you do with Sage? How can you do blah, blah, or blah? So I'll stop and just see what sort of random questions you have for a little while, okay? Yes? That is a very good question. That is an extremely hard question to answer. It takes so much time to write off. The problem is there's just thousands and thousands of functions in each system, and your question is somewhat meaningful for any particular function. But even then you have lots of inputs. Like any function, very often a function has really infinitely many different potential things that you might plug into it. And so you might ask, okay, how fast is Sage compared to Mathematica and Maple at computing factorials exactly? So, let's see. So I'll try to answer that very question, but you'll see that even then it's not the easiest thing to answer. So here's how I'm going to try to do that. So each of these programs can compute factorial. Like a lot of different programs can compute 1 times 2 times 3 times 4 times 5 and so on. So here's a bigger factorial like 40. So you can ask, well, first let me just give you the overview of the answer instead of trying to answer this live. So first, there are a lot of different integers you could plug into the factorial function. You can very reasonably compute factorials up to, say, 10 million in a few seconds for any particular number up to 10 million. So, so that should take about 12 seconds. And that's a pretty big number that we're taking. We're taking the product of all the numbers up to 10 to the 7. So, and it took 11 seconds. You can find other Linux computers where the exact same thing will take 5 or 6 seconds. This takes 11 seconds due to how it happened to be built on the virtual machine that it's running in. So there are issues of how your software was built, what sort of optimizations were included when it was built, and that can make a difference of a factor of like 4 in runtime. The different inputs can make a big difference. Like it could be that one program is really fast for small inputs and another program's really slow for small inputs, but for big inputs it switches around, unfortunately. So it's really, really hard to answer that question. And it can just be difficult to time other systems. I've written a lot of code trying to just to time various things, maybe comparing Mathematica, Maple, and Sage. And in my, like a general rule of thumb in my experience with just a lot of basic symbolic stuff was that Maple, when the input started getting big, was so bad I just had to throw it out and not time it at all. Like it just was so slow, it would take hundreds of times more than Maple than Mathematica or Sage. So I'd give up on it. But every once in a while, Maple will have something that's faster than everything else, because the company that makes Maple hired some postdoc who did something really brilliant who was coding inside Maple. So it's just like a really complicated question to answer for any particular function. And then you have to answer it amongst a very large number of functions. So there's a lot of work. You'll see a lot of talks at conferences and Sage days where somebody will, for example, draw a plot which will show how various programs compare to one another at various operations. And if there are two different inputs to your function, then you have a two-dimensional picture. So you might draw a two-dimensional picture with a color that indicates the relative performance of one system to another. It's kind of like asking which car is faster. You can do the 0 to 60 time, but that might not be what you care about. You might care a lot more about 60 to 80 or something like that. You might care about how fast your car is going around a corner. So it depends a lot on what you actually care about. But it's a much more complicated question than which car is faster. So in short, I don't know. But Sage is pretty good at this point in time. It used to be that for a lot of just basic symbolic calculus type manipulation, Sage was really pretty uniformly slower than the other systems. But that's changed a lot. So there are various areas though where some programs are far ahead of other programs. So for example, linear algebra, where your entries are exact rational numbers or elements of a finite field. This is something that all the systems we're talking about except MATLAB can do, but Magma and Sage are often dramatically faster than Maple and Mathematica at these problems. For example, you have maybe a 500 by 500 matrix with integer or rational entries, and you ask for its determinant. That's the sort of thing that Sage and Magma can do using much better algorithms than Maple and Mathematica. So it's much better at that. In contrast, really complicated symbolic integrals, Mathematica is often much better than Sage. So there's some general things, or at least last time I looked, and these things change. But a lot depends on where effort's been invested in each system. In arithmetic geometry, this area I mentioned before, there's a bunch of functionality in Magma that's not in any other program at all in the world. It's the only system that implements that functionality. So it's a complicated question. So also, another thing that complicates it is for problems like computing the factorial, it turns out that all of the programs use various versions of the GMP library. They use exactly the same code or various versions of that code under the hood. So they use the library, but maybe with different options when it was built, different versions of the library, etc. And that can, in fact, impact the performance a lot. Okay, next question. Random questions. Yes? Yes. Yes, but I don't know how fast the zoom capability is, but you can definitely draw fractals. There's a website called interact.sagemath.org, which I have never really looked at. So some undergraduate last summer completely rewrote this page using, I think, using one of the Python web programming frameworks. So this is a page that's full of what are called interacts. These are kind of interactive widgets where you have some controls and you see some output. So you can use Sage, but without having to know anything about programming or coding at all. And let's see basically you can browse through it and see examples of various calculations using Sage. So I think you can search by a keyword right here. Let's search for Mandelbrot. And then what you'll get, I think, is a snippet of code that you could paste into Sage, and then you get the corresponding plots. So, okay, here's one thing, Mandelbrot fractal binomial measure. I know there's a lot of fractals in here, so that's only one of them. There must be other fractals. Because this isn't really a... this is horrible. Oh, let's try another site. wiki.sagemath.org/interact. Since I know my way around this other site. In any case, yes, there's lots of code people have written for drawing fractals that isn't necessarily included in Sage itself, but it's on pages that users contribute content to. Seems like my network connection is very slow. I don't know if I should switch to exhibitor internet, but on the other hand, maybe it might be good that it's slow, so it slows me down. Fractals, click here. And this will be a section that has a bunch of examples of drawing fractals using Sage. So I'm waiting and waiting for it to come up. I am a very impatient person, which is to the benefit of Sage users. Okay, so yeah, so here's some examples. Exploring Mandelbrot, that looks promising. Anyways. Pages are pretty heavy to load over extremely slow connection. But apparently this draws Mandelbrot, so that's this code right here. Yeah, so there's an example. What happens is you evaluate the code above, and then what you get is these buttons and these sliders. You can drag them, click on update, and this will draw a picture that looks like what's given there. Okay? And you can see it's a pretty fractal. Yep, you'd have to modify the code somehow, I think. But, oh, actually, look. So it looks like they've selected a particular color map from the pylab.cm.gray. You can change that word gray to, I think there's like 100 different choices, and you'll get the numbers turned into colors in different ways. Okay, so the short answer to your question is yes, but the internet's kind of slow, so it's frustrating looking at this. But I could try to copy and paste this into Sage and then try it out. This is, so one thing, so Pablo Angula has written this. Notice this block of code it doesn't look like the Python that I mentioned before. Notice that you have type declarations. You explicitly declare some of the inputs to be floats or ints. And at the very beginning, it has this little thing, %Python. What this means is that when you evaluate this block of code, it takes it and turns it into C code, and then it compiles the C code, and then into a shared object library, which it then links into your running Sage session. And that compiled code is much, much faster, probably 50 to 100 times faster than anything you're going to write just in pure Python. So that's being used here to speed up the calculation a lot. And then down here, the code that was given above is used. So, it might be kind of fun to just try this out. So I can just copy and paste this into the talk. So first, I put the Python code in, and I click Shift-Enter, or I click the Evaluate button. Shift-Enter doesn't work on Internet Explorer for some reason, but it'll work on everything else. It successfully compiled the code right then to C code, or to convert it to C code and then compiled it. And now I'll run the second block. And this compiling thing, that's something that you can't do in any of the other MAs. They don't have compilers that are so easily usable right from the interpreter. They're usually very complicated to compile. Okay, so now I'm evaluating the second block, and now it's actually running. Took 0.2 seconds. Now it's spending most of the time sending the plot over the internet to my browser. And there it is. Okay, so it just drew that plot from scratch using the above code, and the time to draw the plot internally in the computer was far less than a second, and then most of the time was just making the plot appear over the internet. Okay? And we can change these parameters and then see what happens. Like we could make the plot size smaller. I don't know what N or L is, but that has something to do with. And click here, and then it'll draw the new plot. Hopefully, maybe I'm being too impatient waiting. One thing is you can't just, at present, you can't just select an area and then zoom in on it, which is obviously something you'd like to be able to do. Sage will do that sort of thing at some point. It's not clear when it will get implemented, but it's on the roadmap to do that. Doesn't look any different to me, but presumably it is different. I don't know. Okay, next question. Random question. Yes? It has a lot of capabilities related to image processing. For example, I will compress the board of directors of SACNAS. You can try this out yourself on your computer. If you look for interactive image compression in the worksheet, you can just use the find command in your browser. You'll find that there's this box right here. You can click evaluate, and what it does is it runs the code that's above. It creates a slider, and it uses singular value decomposition, SVD decomposition of a matrix, the matrix being the matrix corresponding to this image right here. This is an image of the board of directors of SACNAS. I don't know if you guys know any of these people, but here they are. And when you drag the slider, what it does is it computes a compressed version of that image that takes up less space by approximating the matrix on the right by a matrix that's a lot smaller. Really, it's a product of other matrices that are a lot smaller based on the eigenvalues of the matrix on the right, or rather the singular value decomposition. Okay, so you can compress it a lot if you want. So you should be able to try this out. And just drag the slider and you can see. So this is a little tiny bit of image processing. There's a package called, what is it called? It's a standard Python package for image processing, which, why am I not remembering the name? Which is included in Sage. And I don't know, Python image processing. I can't remember the name of the package. Most questions of the forum, can you do that in Sage, have a yes answer, because Sage is really just a Python interpreter with a large number of Python libraries stuffed in there and put it together in a single comprehensive whole. So in theory, anything you can do in Python, you can do with Sage, with sufficient effort put into it. So yes, there's something called PIL, that's the name I wasn't remembering. It's the Python imaging library. This is included in Sage. We regularly update the version that we include in Sage. And it allows you to take an image and do things to it, like flip it around, apply transformations to it, convert from one format to another. It's kind of like a programming language version of Photoshop, if you like. So this is the website for it, but it's actually inside of Sage. Okay? So you can do a lot of image processing in Sage. But also there's a lot of, this is just using functionality in a library called NumPy, which is kind of like MATLAB-like functionality, very applied math type functionality in Python, and of course available through Sage. Okay, next random question, and then we'll stop and try some examples and stuff. Go to random. Yes. Oops. Just encourage random questions. Yes? Yes. I have something in here about that. So if you type ask into the worksheet that you have there, you'll see that I list 3 different types of forums. There's a live chat, which you can use very easily. You don't have to sign up for an account. You don't really do very much. Just click on this button that says live chat. It takes you to a certain page that you can also find from sagemath.org. What it does is it runs a Java program, so it won't work on an iPad, unfortunately, but on any of your laptops it will work. And it logs you into a chat room where you can talk in real time to other people who are also interested in Sage. It uses IRC. So this is one way to get answers to questions about Sage very, very quickly. So you have to choose a nickname, and then you have to apparently do one of these CAPTCHAs, but it's not a super hard one. And then there you are. I'm now connected to the chat room, or at least I'm being connected to the chat room. These are all the people that are in the chat room. They're listed on the right-hand side. There's quite a few people here. Hi, what is this Sage? So you can ask questions there. Another forum in which you can get answers to questions about Sage is ask.sagemath.org. This is kind of like Stack Overflow or Math Overflow, if any of you have used those sites. But it's special for Sage. So whenever the internet lets this come up, we'll see. But it's basically like you ask a question, and then other people try to answer that question, and you can rate their answers. You can decide whether an answer is valid or not, etc. And you can see that it's pretty heavily used. Each person that signs up can try to answer questions. If they answer questions and people like their answers, then they get karma. And you can see a list of the thousands of people ordered by who's done the best job answering other people's questions. So apparently the current winner by far is this guy, Carl Dieter Crispin, who is a math professor somewhere on the East Coast. And he apparently answers a lot of questions here, but you can see that there are many other people that have answered questions here. And it goes up to page 43, so there are a lot of, at least 43 pages of people like this. So there are a lot of people that look at this site. And so you just ask questions here and then see what happens. So this can be a good way to get answers. There's a third forum for getting answers, which is the Sage support mailing list. This is just a traditional Google group. You send an email message after signing up for the group, and then probably about 1,500 people will see that question, and then they'll answer it through their email. So they each have their advantages. Different people prefer different forums for answering questions about Sage, or asking them. Okay? I'm curious, of these three, who would probably be most likely to use live chat to get an answer to a question about Sage? Would you choose that? Okay, so like one person, right? Who would be most likely to use ask.sagemath.org? A lot of people. Okay, and then what about the mailing list? Okay, wow. So that was a pretty big group that likes ask.sagemath.org. I fall into the mailing list group. I would never use live chat, except I just did. Never mind, I figured it out. Okay. Because I don't know, I feel like I just have to sit there and stare, waiting for somebody to answer. I don't know, just doesn't work very well for me. The Ask site, have you guys used Math Overflow or seen that? So if you have any interest in doing research math ever in your life, you need to learn about the website mathoverflow.net. Mathoverflow.net. This is a question and answer site about all areas of mathematical research. And it's incredibly popular. And basically, they divide things up into different areas of mathematics. It was started by a bunch of Berkeley grad students a couple of years ago. But the sort of people that frequent the list are a bunch of Fields medalists and tons of really good research mathematicians and grad students. And they have extremely wide coverage. They're by far the biggest common forum for people talking about research mathematics. And you can undoubtedly find questions and answers there of interest to you. So you definitely want to know about this site. It's extremely useful for research. It's nice, especially if you're in a somewhat isolated environment relative to the type of research you want to do, because it'll help connect you with other people, like going to a conference would do, but it's more online. So definitely note that if you don't know about it already. And if you liked the middle option, Math Overflow, which I just showed you, is just like the middle option, except for all of mathematics. Okay, so I want you guys to do stuff. So, I don't know, just try doing something in Sage, and I'm going to walk around and answer questions. I know there's supposed to be a break at some point in the schedule, but I completely forgot what the schedule's like or what's going on. So, what? 2:25, okay, that's 20 minutes from now. So, how about if you spend the next few minutes just try some things in Sage. Try typing in anything you want. Try to break it. I don't know. I'll walk around and try to answer questions. And then we'll have the break. And then I'll systematically show you several examples involving different areas of mathematics, which you can also look at in the worksheet. Before you do that, though, let me point you at some additional resources. If you type, let's see. Well, actually, right here, where it says, if you made it this far, next try the Sage tutorial. So if you can't think of anything to try in Sage, just click on that link. It'll make a new page for you, which is a live tutorial, a guided tour, basically, involving different areas of mathematics. So if you're really interested in learning about, I don't know, basic algebra and calculus, or even better, you're interested in learning about basic assignment, equality, and arithmetic, you can click there. And what you get is something that looks like documentation, but you can click on any box, modify it, and click evaluate and see what the output is. So if you want to do something different, you can do that. So if you can't think of anything to try, just click on tutorial, which again is right here where it says the Sage tutorial. Okay, so I'll just walk around and make sure that you're getting somewhere for the next 15 minutes until the break, okay? And Ed Ray and Ellen will help you with that. Just try anything. Yes. So you need to apt-get install. Is it left here? So if I can do a sudo apt-get install live SSO. Live SSO. Yeah. SSO. Yep. Install that. So the error message said that it couldn't find SSL headers and turn it back. That's what it is. That's what it is. And then just typing loop again and review that problem. It's because of license reasons that we're not allowed to do SSL gets saved. The SSL library is licensed under its own weird license that you can automate it. That's the safe licensing. It should check this right when you start the build and give you an appropriate message. Don't forget when the next version of Sage. Sorry about the confusion. Yes. Yes. Yeah, I don't know. I have to know before. Yep. Yep. No, I don't know. Yeah. So, yes. It's asking me. No, never mind. Totally wrong. Totally wrong. I thought it was asking me to There is? You can drag it around here. Different. You can, better yet, you can change the function if you want to get your X squared. So I actually can't do that. You have to make it 2 asterisks of X. Similarly, yeah, then an asterisk. Yep. But wait, no, now if you about to do it. I know that there will be stuff with Python. There's definitely various optimization packages available for Python that you use for Sage. You have a Sage itself that provide constantly. Because you can Sage space operations, But they wanted to draw more, you could change these screws to the derivatives. Yeah, if you want to make it very picture bigger, you could change the screws there, but you can't do it. The 3 is supposed to be like 3 is supposed to be plus. Whereas these are yeah, or sorry, raising your material. You want to switch the tips. One of the voltages you get anyways, but yeah, using your material. Well, if you want other ideas for things to try, look at the process. You can try that. Yeah, it's a function called ODE underscore solve it. So I don't know, but if you type a function and type question mark and then evaluate it, it'll tell you all about it. So yeah, it looks like, yep, look, there's a big list here of things. Yeah. Okay. So yes, and I guess ODE solver was the right name, since that's. basically it uses the Python liquid, and this is a good overview. So like the graphics is like what graphics is like polygon, circle, text, and so on. So the key thing is a bit more help to see examples of this. You can type, if you want to see how to use circle. This is very object. This is one of the first areas. Or actually do this first. Yeah. Yeah, it's just using RGB. Just like that. You can, yeah, to get the letters, correctly decimal, the first two digits correspond to red, the next two digits to green, and the last two digits to blue. So it's like, you can also just get a color like blue. There's a lot. It's a pretty complicated model. Yeah. So it's like right on this one. Yep.
We have a break, now until about 2:40 and about 2:45
Yep, and at 2:45 we're going to tell you how to do things like search, make an object, figure out what functions you can call on that object, find examples, documentation about functions, and so on. Basically, I'll talk about introspection, which is how you can start with one object that you're interested in, and then figure out what you can do with that object, naturally from within Sage. Okay? And that starts at 2:45. And Very similar to matrix. You can make a matrix and run matrix. And anything you can do with a matrix, you pretty quickly. And you can say, please draw this matrix and convert the original matrix overnight certain way. But that's kind of one way. There's also the ability to optimal CM. Use a thing called light. It's a low-level library where we're trying to direct access to very basically a kind of all this well, it's still you want to dynamically change it in the browser. I don't think there's any way to do that. If you want another big deep image, send it to the browser, you can do that very the guy who wanted to put my TV like my topic, right? So we got one of the very yeah, so we can use it. Do what? Sure. Thank you. Espresso is preferred, but a normal coffee would be fine. Okay, cool. Sounds good. Yeah. I switched to math for my last year, but most of the time it's something that I had to do with the memory. Yeah. Yeah. I'm not an associate. I'm full of it. Yeah, in math. Right, I'm teaching a graduate course called Cultivation. Literally, I'm today, right in the I haven't done a series, where at the university tonight? I live pretty close to Portland. I'm called Brandon. Yeah, yeah, it's all the way between Texas and Arizona. Texas and New Mexico. Yeah. I have three PhD students right now. There's another, so for number 3, there's me. There's another professor named Ralph Greenberg. And there's a third person named Neil Coates. Number 30 people. And then there's somebody named Max who does algebraic geometry. The work he does is fairly close to number 3. So we have a couple of people and a reasonable number of programs. Pretty good, not like in the top 5 or anything, but it's also really, I like the university option. Great company. Yeah. It's really university gives opportunities. I wish that number theory, like, there's a confusing thing. If you look at our official catalog and graduate courses, you don't see any number theory courses at all. But we have, for the last 6 years since I got here, there have been at least 2 graduate number theory courses every single year. So, very interesting. Just that they're always taught as special topics courses, like all of them. Very strange. Like, other universities have been at it for just a list of number theory courses. So I could really lobby to change that because they always just say that's wrong. But you're teaching 3 special topics. Potentially, it's a pretty strong department. Certainly a lot of research going on. Yeah, so we have a lot of different the biostats department, the stats department. I think there's an applied math department that does have some. Yeah, there's a lot of my wife's in the public health department. Stats. Personally, I don't really know that much about stats. Like, I know there's a whole department that can say, but I've never actually really talking to them, except for their assistant. When I was in undergrad, I had a pretty good reason. So, it's kind of ridiculous. The first thing that pushed me in that direction was I was browsing in the computer section of newspapers, and there's an article on abstract algebra, which is computer section. And I just asked, I saw it, and I was like, oh, I wonder if this is about. And I started talking about this beautiful structure in mathematics, and all these objects. Things like integers and groups of and I was pretty surprised because I'd never heard about any of that. So that started getting me interested in that. But it's funny because I think months before that I remember taking my calculus class. This is the last class I ever had. But yeah, I was like, oh, then finally. And then I found this book and I got really interested in it. Whoa. That's bad.
It's actually just one floor down. Okay. It was good to meet you. It was good to meet you.
Yeah, so I took the first thing.
Hopefully I'll see you around here. Yeah, I'm going to come back tomorrow for a couple of interviews and stuff. So I might run into you. Okay. Bye.
Graduated math, I could just take a whole bunch of classes in engineering. Graduating computer science, I had to take at least 2 more years of courses in a very particular computer science engineering department. And it was very rigid about what courses we had to take and when they were offered. So I graduated a year earlier. I figured it was going to be and also finding math to seem like the programming was just learning how to program it. So writing math, all these things. So big. Figuring stuff. At least back in the any professor that gets to be very successful in that department, who's back then get hired in the industry. Like every professor is good, secure. I think our math department is a lot better. At least we have a math department. Something we like. You have a question? Thank you for working on I know Scott Hannon. Scott Hannon. I went to grad school. He was a math. So we're going to see the direct line to, oh, is that? Yep. Yeah, I used to, what do you think the right that? Yeah, you see, I'll check it out. But my mate asked me about that, so you can show people. That's a good thing to show them. Yeah. But yeah, I do like to get right. Yeah, yeah, you can make the matrices work out really nicely. Yeah, it's really awkward. Rob Easter does that a lot. I think he's added functions, like the random matrix function in Sage has funny options to make a random matrix which reduce threshold form, almost denominator that we go, stuff like that. So, yeah, it's been a lot of fun. Yes, let's see. This is called the thinking project. We got to speak at FRG grant. David Farmer, this is the sort of thing that we just wrote another proposal and submitted to the second. I kind of use the way instructional like to see that exactly the sort of thing you mentioned in topics but there's exactly the sort of discussion pattern muffins I don't know about that or anything yet. And I think the same happened when I looked at that section of the proposal. So you might want to show David Farmer and ask him exactly the same thing. But maybe Paul Dunn. David Farmer is very good. Other questions? Yeah, but I just want to get the word they want. Sure. You might have trouble getting a seat because a lot of people go out there and fill it up. But it's easy to sit on the side or on the those chairs in the center. Okay. Bring your chair in for that side. Welcome. Yeah. Do you like a place that is really good? Yep. In fact, you have a laptop? Yeah. Okay. What you should do is go to, well, basically go to my website and it'll go to wstein.org and there's a big link right in the middle that says SACNAS. Click on that and then do the two steps that are listed here. Okay, yep. So wstein.org, SACNAS. Yeah, yeah, my impression based on my data was that compensation is very difficult to get expenses, maybe, and maybe employee extensions. It might be difficult to know what to do about because of policy. Whereas you can do other things about that space using homological yeah, there was like a heated discussion about where Paul was like, okay, also the proposal probably doesn't say anything about this now that I think about it.
Is it like on your website?
Let's see. I think it is possibly secretly though,
Okay.
but I can give you the link.
Okay.
Okay, I think we did not post it, but
Okay.
the link exists. I'll send it to you. Whoops.
Okay. I mean, I can easily just send.
It's secret though. The link is secret. Still secret. Why is it still secret?
Wait, no. If this is the same FRG,
No, we just submitted it 2 weeks ago.
no. I'm just going to say no. David Farmer sent Jamie Wygant an email asking him if he wanted to be on the FRG.
That's entirely possible. As a
I mean, I
support.
don't know if
Or
Jamie
did you
would.
send him the actual FRG application?
Probably not.
So,
Because yeah, 'cause I think Jamie was still trying to wrap his head around what an FRG would be.
here is the link. Guess we're starting again very soon. 25.
Yeah. Yeah, but no, this is excellent so far. This is really good. I mean,
Cool.
I'm learning a lot of stuff about Sage that I didn't know before.
Yeah. What I'm going to do now is just like, here's how you do task completion,
Mhm.
introspection. That's
Uh-huh.
basically, because I didn't do it at all, which is normally the first thing I would do.
Right.
But let's see. So, where's my text my wife and thinker?
Okay.
This is a very high priority.
Yeah.
She just ran off.
Yeah.
Sure. Okay, so
So at least I have bragging rights. I can say that I remember when the two of you were just dating.
wow, that's a long time ago.
Yeah.
Okay, good. So that'll give you the FRG, which
Okay, so that's the link to it. So.
yeah,
Okay.
I doubt it's going to help you much in answering that question.
Right. No, it's fine. 'Cause I mean, this grad student, to be honest, I don't know if he's strong enough to actually solve this problem, but I've been thinking about it on and off for about the last 5 years. So I figured I'll give it a shot, see if he can do it, but I really want to see has anybody
What was
tried
the?
to do this
Do you remember what the credentials were for this network for the exhibitor internet?
before. Vols, VLLS,
Yeah.
and
Let's see. It's
I think it's
faster.
Alejandro. I don't remember the password now. Math 1? Math?
Maybe it's math. Let's search my email. I think she emailed it to me.
Okay. Yeah, really, this whole thing's been Alejandro's thing. I've barely been involved with it. She's been emailing back and forth, getting it all set up.
Yep. Balls math. Yeah, the network is ridiculously slow for me. I mean, insanely slow.
Wait, so
It's like
there's a
slower than my
difference
cell
between-
phone.
So,
I'm on the free network. Okay, it's Balls math. I haven't tried
Okay.
the exhibitor internet. Definitely the free one is amazingly slow. Like,
okay, yeah, I figured that it would.
yeah, Balls internet or Balls math. Okay, Balls math. I mean, we're talking painful.
Right.
It's So I'm hoping this will be a little better.
I mean, maybe you're just hiding it really well, but it seems like you're not having any trouble at all.
I'm trying very hard to hide it.
Okay.
Well, that feels better. I think that's way faster. So we're putting a roof on it like that. Yeah, it looks like it's way faster now. Massively faster. Okay. Wow.
No, that whole ramp thing is just crazy.
Massively faster. Okay, a million times faster.
Okay.
Awesome. Okay. All right. Should we start? There's some people not here, but
We're missing
a lot of people. But there could be some people who aren't coming back.
Oh, right.
So I think we should. What time do we end? 3:40? 3:50?
That's about right. Just to make sure. Yep, 3:40. You're supposed to start back at 2:45.
Okay.
So yeah, if we only have like an hour, then I would say just go ahead and start.
Yep. Okay, so let's do that. Oh, so much faster. Massively faster. All right, so I think we're going to start again. By the way, I just tried logging in on the official Wi-Fi network that's called Exhibitor Internet, and it's like 1,000 times faster than using free Wi-Fi. So just in case, just pointing that out, that it was really, really slow, and now it's really, really fast for me. So watch out for that. Okay, so we're going to get back to the worksheet we were looking at, and I'm going to actually give you sort of step-by-step guide about how to do stuff in Sage, rather than just saying there's a bunch of things you can do and the system's really nice. Here are some examples. Now I'm going to show you how to make an object and find out what you can do with that object. And also how to, if you wonder, is there something in Sage to do blah, I'll show you some ways to try to answer that question. Okay? So first, let's suppose we want to do something with matrices. So I can type the first few letters of the word matrix and then hit the tab key. There's no way to do this tab key thing on an iPad, unfortunately, yet. But, and I hope it works in Internet Explorer, but definitely in other browsers, it'll work fine. And you'll see a list of all functions that begin with those letters that you just typed. So this can save you a lot of time, since you can just start typing the beginning of a word, hit tab, and then it completes it. So then what you can do is you can start calling the function. You're going to call a function, so you put in open parentheses. If you hit the tab key right now, it pops up the documentation for that function. So for the matrix function, the function that makes matrices, it pops up the documentation. And this is some extensive documentation, in this case. What you'll find for I don't know, at least 85% of the functions in Sage, you'll find a quick description of the function, and then a paragraph or so that describes the function in more detail, and then a list of what the inputs and outputs of the function are. And then finally, you'll often find a large number of examples, which illustrate how the function works. So these are examples that you can copy and paste, and they will actually work. Unless otherwise explicitly noted by a comment in the margin which says something like not tested or broken, every single one of these, unless otherwise explicitly noted, is tested on about 20 different systems before every release, and every single one gets tested. So it's not like this is out of date and we changed Sage, and this example used to work, and we forgot to update the documentation. If that happens, the documentation would break, because we run this code automatically, so there's like well over 100,000 lines of input like this. We run it all in parallel on big computers, and check that the output agrees. There's lots of cases where the output is maybe a little bit random. So in that case, we do things like use a random number generator with a consistent seed, so that we can still do the testing. And if that doesn't work, we have a special tag that we use. So you can just look at any of these examples and try them out. So if you're one of those people that likes to just copy and paste things that definitely work and then modify them, which I like doing personally, you can do that a lot with Sage. So these are tons of examples of making matrices in various ways. So just for fun, let's take this one. So you copy it out, By the way, if you want to make a new cell to type input into, if you move the mouse until you see a blue horizontal line, either above or below a cell, like this, then you can just click on it and it makes a new cell. So you can do that, and assign this to a variable, and we get a matrix. This is a sparse matrix in the sense that the underlying data structure is sparse. It's a 10 by 10 matrix. The entries are integers, and they're constructed using the range of numbers from 0 up to 100 minus 1, from 0 up to 99. So that's where this comes from. Once you make a matrix, you can then wonder, what can I do with this matrix? How do I compute its characteristic polynomial? How do I compute its determinant? How do I do things with it? If you do A, if the matrix is called A, you can do A dot, and then hit the tab key, and this will show every single function that you can call on the matrix. So there's a big list of them. A very, very big list of them. These are all the functions that make sense for a matrix with integer entries. So, for example, we can do things like, is it the one matrix? What are the eigenspaces? What is its kernel? What is its rank, etc. So let's do that one. I clicked on rank, and then you call the function with parentheses, and it will give us back the rank. Okay? You can then wonder, okay, what is this rank function? Maybe, okay, rank, you probably already know what that means, but if you want more documentation about a particular function, again, you just set things up as if you're about to call it, and then you hit the tab key, or alternatively, you type a.rank question mark and then click evaluate. And this will give you the documentation for that function on a matrix. And it will give you lots of examples of how to compute the rank of a matrix. Well, actually, this case only has one example, and it's not a very good one. I would prefer a better example. So the only example of rank for this function is one example that illustrates that a certain subtle bug is fixed. So I could think of better examples to add here. If Sage were more like Wikipedia, I'd click something right here, add a better example, and then submit it to get included in Sage. It's not like that yet, but it will be someday. Okay, so what I'd like you to do right now is make a matrix. So remember, you can figure out all the different ways to make a matrix by doing matrix question mark and evaluating that. Make any matrix you want, assign it to a variable, just like I've done here, and then do a.tab to see the various functions that you can use, and try one of them out. Okay? Try any one you want. So make a matrix and do something with it. I don't care what. That's all you have to. That's your mission right now. Make a matrix and then do something with it. There's also a command random matrix. You can't think about numbers to put in your matrix. You can do random underscore matrix. That's another way. So I'll just record that right here. Yes. I have at least one. I have one. Yep. Unfortunately, using this one. But if you click evaluate, that should work. You're logged out of the internet, so that's not helpful. And the Sage Notebook doesn't do anything really sensible to say, hey, the internet connection is not. That's I guess you have to read it. And then, I blame everything. It could be the same problem with Basically, I never did that. Yeah, quite a lot. But it's going to cut it from this one to the default. You can look at the top of the top and that it's roughly doesn't fit. So if you do this, you also see Oh, Oh, wait. Oh, what do you have? What does that mean? Like the minimum and maximum? Yeah, in the middle. So there's a curve range all by itself and no A dot or anything, which gives all gives one. Oh, right. Yeah, because sides are here. Yep. Yeah. Yes. That one does. That shouldn't happen. Oh, that's what you're using internet square. No. Oh, the what you're using is lower network. Basically, it's not all the after tap. There's another way to get a list of all the methods. You can do like DIR, and this is it. No, like, DIR, right? And that doesn't require like the directory did. And that gives you a list of everything. Okay, so hopefully you did something with the matrix. Did everybody do something with the matrix? Did you make a matrix and do something with it? Excellent. By the way, some workarounds from just walking around. Some people had trouble when they try to do a.tab. Maybe you're on an iPad where there's no tab key. So, or maybe your computer's just working strangely. So if you have no tab key, well, it would have been great if somebody had implemented a little button right here, which is tab. But nobody did yet. But one thing you can do is you could type dir of a, and that will give you a directory listing of everything that you can do with the object. It's basically the same as what you get from doing a.tab, except it returns it as a list of strings, and also gives you a couple of extra things that are supposed to be hidden. Okay, so just showing you that again, since it scrolled by dir, directory of an object. It's like it looks up all the stuff that you can do with that object. Okay, so mentioning that, it doesn't require hitting a tab key or anything like that. Okay, let's see. So one thing that I haven't systematically showed you very much is plotting. So I think that would be a good idea. So let me go down and show you, talk about some of the examples involving plotting in the worksheet. Here's an example of how to plot a function. So you can define all kinds of functions in Sage like you would define in calculus. You can do things like f of x equals, and you can use all these standard special functions. Cosine of sine of x plus tangent of x minus secant of, I mean, that's all trick stuff, so log of x, etc. So you can define your function. It can be really complicated and scary. You can also do show of the function, by the way, and it will give you back a nice typeset version, which is a little easier to look at. You can do, if you use LaTeX, you can type LaTeX of your function, and it will give you back something that you can paste into a LaTeX document, which is nice. And finally, you can say plot, give your function as input, and it will plot it. This function appears to have blown up somewhere, so I think the logarithm was the reason for that. So I'll make the range of x values a little bigger. So, oh no, it blew up somewhere else. Tangent, oh no. How about 5 to 7? Okay, good. So I got a nice plot there. There are an enormous number of options to the plot command. This plot command is not, it's a pretty sophisticated plot command. So, I mean, it started out simple, but then it kept getting more and more complicated. If you do plot and get the help on plot, you'll see that there are a large number of options. What it does is it takes your function, the plot, which is a function of one variable, and it starts by evaluating it at 200 points. But it's not 200 equally spaced points. They're slightly randomly positioned. This is to avoid problems like if you take your interval and divide it into evenly 200 points, you can sometimes use a periodic function to construct one where the plot looks flat, even though the function jumps all over the place, just because it happens to be applied at all the sample points. So to make that very, very unlikely, the sample points are randomly perturbed just a little bit. But then after doing that, it looks and says, hey, if the change in the function was really big between two adjacent points, let's fill in some more points there. So it adaptively refines the plot recursively up to some level of recursion. And so you're likely to get a plot that will look really smooth and will not be smooth. Okay? So there's that. Then there's all kinds of parameters you can control. You can control the color of the plot. You can use an RGB color like you would have in HTML, like hash RGB. So a little bit of red, a lot of blue, and no green, for example. So you could draw that plot, and let's see, plot's probably below my, oops, what is wrong? So there's my green plot. You can change things like the thickness. So I want it to be really thick, for example. You can do that. You can change the size. So, whoops. Oh, so that thing finally appeared. You could do fig size equals, I don't know, 6,3. You should think, man, my browser is catching up. Oh, I did fig size twice. You can't do that. So I did fig size equals 6,3. Think of this fig size as the size in inches. So it's supposed to be 6 inches wide and 3 inches tall. So that's what that parameter means. There's a lot of other options. So for example, you can make grid lines by just saying grid lines equals true. And it'll give you grid lines. You can control everything about the grid lines. You can make a function that determines what parameters are used, like what color the grid lines are and so on. You can control the axes. You can decide whether or not, like you could say frame equals true, and instead of drawing an x and y axes, it draws a box around your picture, which for certain types of data looks a lot better. You can also add together different plots. So I made this complicated plot. I can make another plot of a different function, say sine of x from 5 to 7. And now I can take these two, maybe I'll make this one magenta. I hope magenta is defined here. You can do g plus h, and that'll superimpose them on top of each other. So that black line's the x-axis. So you can combine together a whole bunch of different plots by just adding them together. Yes? Yes. There is a, let's see, so what is it? Grid, plotter, I can't remember what it is. Graphics array, that's what it's called. Graphics array. So you can give a collection of plot objects as an array, and it will draw them all like this. So this one's kind of big to see, but if I change the, oh, I guess I can't do that. But see, what this has done is it gives me, well, I can make it more like this. So you can, basically you give a list of lists of different plots, and then it will draw them all together on one big plot. I think that's what you were asking for. A lot of the plotting in Sage will be familiar to you if you know Mathematica. Basically, the way plotting started in Sage was this undergrad, Alex Clemishaw. I said, hey, look at the Mathematica documentation and change the names of the functions to follow the standard Python convention of lowercase with underscores. And then just try to implement all the same functions as you have in Mathematica for 2D plotting. And he just sat down for several months and did that. So there's a reason that there's a similarity. So if you know commands for plotting in Mathematica, you can often just use the same ones, but with lowercase and underscore instead of capital letters for the names. So there's that connection. Yes? It does behind the scenes use matplotlib to actually render the image, yes. And you can use matplotlib directly if you want, and that will give you an interface to plotting which looks very much like MATLAB's interface. So you can use both. So yeah, matplotlib is fully available here as well. Okay, so you can superimpose plots. Often you want to experiment with a plot. Like let's say here we want to vary the minimum and maximum. Or actually, just to make it really simple, let's just say we want to plot from 5 to some max value. So you can put this all in a function, like this, then you could just sit there and call the function with different values. But another thing you can do is say, oh, my x max is going to vary between, I don't know, 5 and 20. And you can put this thing right ahead. You put the @ sign and interact, and it will construct, oops, what is wrong here? Oh, I think basically I need to start at a value that's bigger than 5. Yeah. What it will do is it'll construct a widget for each of the inputs to your function. What I did here is I put @interact before the function. It constructs a widget for each input, and then I can dynamically change that, and it will reevaluate the function with that modified input. It's a little annoying that it gets really big. That was the nature of my function. You can change the parameter. You could say show it, but I want the y min to be at most -1 and the y max to be +1. That'll clip it between -1 and 1, which apparently was probably too aggressive. So that way it doesn't get chopped off. You can change lots of things, and it will figure out a widget for each parameter. So like you could say color and have some default, and it'll figure out a widget for adjusting the color. Okay, and so here's the widget for adjusting color. So you can just choose, oh, I want it to be that blue, and you click OK, and it makes it that blue, that color of blue. And there's probably like 15 or 20 different controls like this. So you want it to be yellow, just click there and you get yellow. Maybe you have to, invalid color hash undefined. I think I used this thing wrong. Maybe I have to do, why does it say undefined? That's stupid. This color selector isn't working. Someone broke Sage. Pissed. Wow. Okay, I found a bug. The color selector is saying hash undefined. Should never do that. So that's really annoying. In any case, if you want to find out more about Interact, which is super useful because it allows you to make all these widgets without having to do anything except define a function, put @interact in front of it, just do help interact and click on the link that you get, and you'll find all the help about it. There's lots of examples in here, and you can use them. And that website I showed you before with the called interact.sagemath.org, which you can find by Googling for Interact in Sage Math. This is just a large number of interacts. So you can sort of graph, like you want to make graph paper. Okay, there's apparently an interact for making graph paper. So this is the code. The cool thing about this page, by the way, is you can, without logging into Sage Notebook Server or doing anything, you can just use all of these interacts directly on this site. You don't have to copy and paste anything, just right here, immediately available. So this one makes graph paper. I have no idea why that would be useful, but, etc. Okay, so that's interacts and plotting. Let me show you a little bit more about plotting. So the plot command is one command for plotting. There's actually a ton of different commands for plotting. You can draw circles, you can draw polygons, you can draw dots, you can superimpose them, as I mentioned. To find out a lot more about plotting, what you would do is just go to the top where it says help, and then you can go to the reference manual. The reference manual is an absolutely enormous document if you were to print it out. It has a table of contents, and you'll see that there's a chapter that's called 2D graphics. And this is just full of information for drawing 2D plots. So let's suppose you want to draw, I don't know, ellipses. So you just look right here, you click on ellipses, and it will show you lots of examples of drawing ellipses, or things related to ellipses. And you can evaluate these examples if you want to see what they look like. So there's this ellipse, and you're like, oh, well, I'd like to try ellipse with different parameters. And you can just try them out and copy and paste them into your working Sage session. Okay, so that's 2D plotting. There's also an enormous amount of 3D plotting. And again, the reference manual will give you just a very systematic description of all of it. So if you want to learn about 3D plotting, you go here. A similar thing happened with 3D plotting. A lot of functionality is similar. Names of functions are similar to what's in Mathematica, etc. So for example, there is, well, like there's a function plot 3D, which takes a function of 2 variables and will plot the corresponding surface. A pretty sophisticated function is called implicit plot 3D. So implicit plot 3D, what you do here is you have to define some symbolic variables, but then you can give it a function, and it will plot everywhere that the function is equal to 0, or in this case, where a certain inequality is satisfied. So this is a 3D plot that was just produced in real time by Sage. The underlying code for doing 3D implicit plotting is pretty sophisticated. I don't actually know it very well, but I know where it came from. This guy who works, or worked in Renton as a computer vision engineer, wrote a bunch of code that draws implicit plots, or at least computes, given a function where the zeros of the function are in 3D. And he kind of like halfway finished it and handed it off to us to see if we'd do anything with it. And this freshman undergrad came by named Bill Cowchoice, and he said, "Do you have any projects for me? My brother writes video games, so I like graphics." So I suggested working on this, and he finished the code and then got it into Sage and got it to work nicely. And that's what you're using here. By the way, so show viewer equals tachyon shows it as a static rendering, but if you get rid of that and have Java, which most of you will have, then it will draw it as a normal 3D plot that you can rotate around. Although it's taking a little while to start Java, but it should finish very soon, hopefully. And then we'll see a 3D plot, which looks like what I just showed you. I'm going to put that over there while I wait. So that's how you do plotting. So plot 3D. Here's some other examples of 3D plots, by the way, where you can see how you can rotate them around. By the way, if you right-click, I think, you can change the style of the plot. There are a whole bunch of styles that involve 3D glasses, for example. Those are kind of fun. If you have red-blue glasses, or you can try a cross-eyed view. Although this is, I don't know if you can see that, but let's see, I want to zoom it out a little bit. If you cross your eyes, maybe you can see that in 3D. I don't know. You can start them spinning by hitting that menu and say spin on, and then it'll just sit there and spin around. It's kind of nice. Let's see. This thing still hasn't appeared. For the record, I'm not a big fan of Java because it sometimes doesn't work. There's a weird issue where if you have, basically each web browser has this really, really small upper limit on the amount of memory that Java can use. And that memory limit is extremely easy to hit when drawing 3D graphics because they use a lot of memory. And so I think that's why this isn't appearing. There is work in Sage to make it so that at most one Java applet is live in any given page, which helps deal with this memory limit. But personally, I think by far the best thing would be to rewrite all this stuff that uses Java, which is only the 3D plotting, to use WebGL, which is faster and much more efficient. But I have one undergrad who's been looking at that, but it's he hasn't got very far yet, unfortunately, because it's actually really hard. 3D graphics are very confusing. Okay, let me turn off spinning. In any case, the stuff you can generate, though, is very, very nice. It looks pretty. There's pretty good support. So initially, one of the big problems with drawing 3D plots in Sage is that we wrote all this code to draw 3D plots, but for things like implicit 3D plots and so on, you have to evaluate the function that you're plotting at a lot of points. And so that ended up slowing everything down. You'd say, hey, I'd like to draw a 3D plot of this function, and then this thing would go off and evaluate the function at 1,000,000 points to get a nice smooth plot. And our evaluation code was really stupid and slow. So one of my students, Robert Bradshaw, wrote a compiler that turns the function automatically into some internal form that can be evaluated very, very quickly, and it sped up plotting by a factor of about 1,000,000. So instead of it taking a noticeable amount of time to evaluate the function, So to construct this plot, now that was how long it took to evaluate this function at a lot of points and make the plot. Now the time's totally dominated by just transferring the Java applet to the viewer. So that's what takes all the time. Okay, so that's 3D plotting. There's a lot of functions there, not just plot 3D. So as I showed you in the, I think in the help, there's implicit plot 3D. You can also draw a whole bunch of different platonic solids. I don't know, somebody name a platonic solid. Icosahedron. So there's a function Sage icosahedron. You just do that, and it draws it as a 3D plot. So it should appear, and there it is, as you can see. So there's tons and tons of objects like this that are in Sage. And you can make them transparent, which is kind of fun. So like, you can do icosahedron with an opacity of 0.7 and make it red. And then you could add to that, somebody name a different platonic solid. Cube, okay, cube. Make this one somewhat opaque with the color green. And just like with 2D plotting, when you add together two plots, it superimposes them. So what this did is it made each one somewhat transparent, and then I added them together, so it superimposed them on top of each other. And now I have an icosahedron with a square, or a cube stuck in the middle of it, which is kind of cool. And you can adjust the opacity, so I don't think this cube is, I think it's too dark, so if I do 0.4, then it becomes more transparent. So see how it's now more transparent. So you can see through it more. So you can imagine there are a lot of possibilities for drawing sophisticated 3D images using this sort of functionality. Okay. For example, as you've probably all seen already, oh yeah, here's a bunch of random spheres, but as you've probably all seen already, if you go to the very bottom, there's an example of drawing a 3D model, which is defined by a bunch of data. So it draws a picture of Yoda. Okay. And I think this involves 30,000 or 50,000 triangles. It's a pretty high resolution image. So we wrote this code, I think, in 2000, like very late 2007 or early 2008. And I don't know, how many people here successfully actually saw a 3D plot on their computer? So it's the majority of you. It's pretty challenging displaying 3D images in browsers, especially back in 2008. Java, there was something called Java 3D that could do it, but in order to start it up, it would try to use the high-speed optimized 3D rendering technology in your browser. And due to security issues, you'd have to click a whole bunch of I agrees, and this, like all these security exceptions would go by. And after you click a lot and download a lot, you'd eventually maybe see a 3D image. So some people teaching chemistry had written something called JMOL, you can look at their website, for drawing molecules using just 2D Java stuff. Basically, no 3D acceleration at all, so you didn't have to click on a whole bunch of terrifying warnings in order to see a molecule. And I noticed this in some blog post about Sage, like just farther down the same page. And Java needs your permission. So I noticed this, and then me and another student, Robert Bradshaw, who I mentioned before, adapted this molecular viewing program to display mathematics images. So that's where the current viewing or rendering code comes from. Nonetheless, I think nowadays it should be possible to do something better using WebGL. But at the time, it's pretty neat because you don't have to click on, you probably didn't have to click a whole bunch of security warnings, just maybe one warning that says I allow Java on this page. That's it. This doesn't use any 3D acceleration at all. It's just purely 2D rendering in your browser. And it's still fast enough to show 3D like this, even at a high resolution. Okay, so let's see, what else I desperately want to show you. Some people are asking about drawing matrices, and here's a cool function that's pretty nice. So let me do something based on this. There's a function on a matrix called visualize structure, and I'll just make a random 500 by 500 matrix. with real number entries. RDF means the real double field. And it looks like, that's not very exciting. It looks black, doesn't it? That's pretty boring. Maybe instead I'll make random integer entries. Yeah, okay. So there's a matrix, I just foolishly tried to zoom out. Okay, so random, okay. So there's a random 500 by 500 matrix. Its entries are various random integers, and that's what it looks like. So you can quickly plot a very large matrix. It's kind of fun to take that matrix and square it, and then draw the resulting plot. So you see what happens when you, to the random structure. It becomes random, but with kind of a different distribution. So squaring it is actually pretty hard. It's a 500 by 500 matrix over the integers. Squaring one with real number entries would be fast, but there it is. So now there's just a few entries that are big enough to see. They're kind of dominating, and the rest are really small. What this is doing is it's converting the matrix into a plot where the smallest value in the matrix is an absolute value, the black color, and then the bigger values are brighter. So it's kind of weird, this sort of stuff you can see with this. Another question, a lot of people asked about optimization, and there's a lot of things in Sage for numerical computing that you might not find in the reference manual. For example, for optimization, there's a library called scipy.optimize, and if you do import scipy.optimize, scipy.optimize.tab, then you'll see a whole bunch of functions related to optimization. So that is like finding the maximum value of a multivariate function, finding the minimum value, etc. Or maybe a single variable function. So here's this bisect, scipy to optimize bisect. There's a lot of really powerful code in there for doing this sort of thing. Okay, so that is pretty much concluding the tour. I'm not sure there's anything else that I really desperately wanted to show you. So let me just kind of summarize what's happened. From the top. So a quick summary of everything. So Sage is this free open source math software system. It's meant to do things in pretty much every area of mathematics that you can imagine. It may or may not actually do so, but that's its goal. I showed you an overview of the history of the software and what motivated its development. And then I gave you a bunch of examples of how to use Sage. And I showed you how to get help about Sage, like ask.sagemath.org, the mailing lists, and so on. And then I also showed you that if you create an object, you can do that object.tab and see all the functions you can call on the object and how to get help about those functions. There's lots of 2D and 3D plotting when you want to visualize the calculations that you're performing or the results of the calculations that you're performing. Sage itself is really a Python library with lots of functionality bundled up into that Python library. So if you're really serious about using Sage and you wonder, can I do something with Sage? The real question is, can I do it with Python? And if the answer is yes, then yes, you can do it with Sage as well. So Sage is good for combining these various things. One thing I didn't mention is that Sage has interfaces to other systems. I forgot to show you any examples of that, but I have one little example right here of Octave. You can use Octave from Sage. So the way you use other systems from Sage, first, if you do sage.interfaces.tab, you can see a list of the different systems that are available. There are quite a few. Well, there's a whole bunch. But you just give it some code to evaluate. It gives you back an object, and you can call functions on that. But what happens is it starts up another process running. So in this case, it starts an Octave process running, and it feeds code to Octave and gets code back from Octave, gets results back from Octave. So if you know how to do something in MATLAB, since Octave is very similar to MATLAB, you could possibly do it this way. Alternatively, you can do things like, if you type %octave, the top of the cell, then you could say x equals rand 5, x, and here it just exactly sends that code to Octave and then displays the results. So if you had a little snippet of, say, MATLAB code, you could put %octave into Sage and have it do that evaluation. You can do things similar to this with Maple, Mathematica, etc. from Sage, but in order to do that, you have to have those programs installed. Obviously, I don't have them installed here, or they would get very mad at me. Okay, so that was the last thing I showed you. So in summary, Sage can do a wide range of things, but it also can't do a wide range of things. Most of the development is volunteer effort. Anyone in this room could easily end up submitting something to Sage, just like anyone here might change Wikipedia in some positive way. And that is everything I wanted to tell you, but I'm happy to take additional questions. Thank you. Yep. Yes. Yes. So if you search for a PDF in the worksheet, you'll find an example of this. G is a plot that was created above. If you just say save and give a PDF file name, it will save it to a PDF file and then give you a link to that file. So for example, if G equals plot the sine function from 0 to 10, and then I do this, it gives me a link, and then I could just click on that link, and it downloads it. It's a PDF file, and now this is a PDF, which means that you can zoom in or out, and it doesn't lose any resolution. It's scaled vector format. So it's in the worksheet I sent. Just search for the word PDF in there, in the worksheet. But all it is you just take any graphics image in 2D, and you say .save, and then you give the, oops, finish loading. You just give save, and then you give the name of the file. There's other formats besides PDF, by the way. Like you could do g.save a.ps if you like PostScript for some weird reason. But look, there it is. It's a PostScript file. You could do g.save a.svg, scalable vector graphic, and it actually displays it right there, which nowadays works, I guess. You could do g.save. I don't know. There's a couple of formats. They're probably, yeah, EPS, PDF, PNG, PostScript, SOBJ, and SVG. But the PDF one is super useful because you can include these in LaTeX documents, Word documents, whatever, and they look really, really good. You can get images. So let's see, plot 3D. If you look at any of these plots, there's a if you want to get an image, you can click Get Image. And what that does is it gives you a static image, I think in the same position as you've positioned your plot. So you move your plot until you like it. So you're like, oh, that looks beautiful. And then you click Get Image, and then it gives you that. And then you can click Save Image As. But it's just a PNG image. There's no PDF form of a 3D image. Because there's all these shadows, and it's really best represented as a PNG. So that's what the Get Image thing is about, though. It gives you a static image suitable for inclusion somewhere else. Which fonts? In 3D, no, but in 2D, yes. So, yeah, let's see, how does that work? Okay, like here's an example of a plot. Let's say you really wanted to put some text in here. You could do something like text. I wanted to say pi at position 2, or actually I wanted to say x squared at position 1, 1. And that looks really horrible. But what if I'd really like to have LaTeX? And it gives me LaTeX. Okay? And I guess I could do font size to make it bigger. So yeah, you can render beautiful LaTeX expressions right there in your plots like this. So, yeah, and this maybe it would be more exciting if I moved it down a little. There. So it's really part of the plot. But yeah, you just use dollar signs. You have to watch out because backslashes are common in tech, and backslashes are escape in Python strings, so you have to use 2 backslashes in a row. That's all. Or, alternatively, you can use 1 backslash and put an R, which means raw string, which means don't escape anything. So, okay. Any other questions? Yes? Yeah, that's a good idea. I will take exactly the worksheet I made, and right here where we started, at the beginning where it has the I will, not surprisingly, I'm going to make this link smaller, but it'll still be findable. I may move it to, I have a section called Talks, which systematically lists every talk I ever give. That's where I'll move the SACNAS link. It'll be number 1 here soon enough. And then I'll put, right here, I have the original worksheet we started with as a PDF file that you can read on anything easily, as a Sage worksheet file which you can download and put somewhere else. I'll put another link which will have the one that has all this mess of stuff I've typed in as we've gone, okay? And that will be right next to these. So you'll be able to download it that way. SWS is the format of a Sage worksheet, and you can download it and then upload it to any Sage notebook server or your own copy of Sage. Alternatively, you can right-click, copy the link, and then given any Sage notebook server running anywhere like this, you can, at the top, there's some file menu. Having trouble getting my scroll bar to work. Okay, so at the top there's a file menu. You could do things like load worksheet from file, save the worksheet to a file, print the worksheet, and so on. Here I want to load the worksheet from a file, and I can just give a URL right here. And it will grab the worksheet from that URL. Although, yeah, that should work. So that's one way you can get a worksheet into this program. You can also do new worksheet if you want a new worksheet. If you click on home, you'll see a list of all the worksheets that you've been playing around with, etc. Okay, any other questions? Or yes? I didn't even say. So if you want to install Sage yourself instead of using, so first the canonical kind of free way to use Sage is click on Try Sage Online. This is a Sage notebook server that has like 100,000 accounts on it, and it could easily get really slow if a lot of people are using it at once, right now at least. That should improve. But you can also click on Download Sage. If you click here, then it will auto-detect the operating system that you're using to click on there. And then it gives you, there's a bunch of mirror sites around the world. You can choose the one that might be fastest for you, or you can get it from BitTorrent or whatever. And then you can choose the type of computer you're on and download Sage that way. So it gives you a DMG for OS X. If you're using Linux, then you'll get a different thing, and if you're using Windows, it's yet another thing. So click here for other systems. Let's see. So for Windows, there's instructions here. Basically, with Windows, you have to download this massive 1.5 gigabyte file, which defines a Linux virtual machine that has Sage installed into it, because there's no way to build Sage natively for Windows. So that's the way it's distributed. And then there's directions for how to use it. And on OS X and Linux, it's a lot cleaner in that you just download a binary, extract it, and you go. So, yeah, on Ubuntu, well, if you have Ubuntu, then, or you mean you already have Ubuntu installed in a virtual machine in Windows, then you could download the Linux binary and install it directly into Ubuntu. Or you could build Sage from source in Ubuntu as well. That works fine as well. So if you know anything about using Linux yourself in a virtual machine in any way under Windows, that's another way to use Sage. But Sage doesn't work beautifully and painlessly for Windows without using a virtual machine, sadly. Because Sage is like 6 million lines of code, and I don't know, like at least 50% of it was written by people that don't ever use Windows or have anything to do with Windows. And they've written for something called the POSIX, which is a kind of standard version of Unix, and Windows kind of is very different, very, very different. So a lot of things don't work. There's been a lot of work to try to make Sage work under Windows, and people are always talking about it, but it's never really happened. I don't know what it will take to make it happen. Okay, so any other questions? Okay, the mailing lists have lots of traffic, and there's lots of ways to get answers to questions online and so on. So, cool, thank you again. And by the way, apparently I recorded the whole thing, so I'll post this on YouTube and right in the same page. So if you want to watch any of this again or show it to somebody, you can easily do so.